Okay, so welcome everyone, and let's get started. If you can hear me, please send me a chat message. Great. So today I'm going to start with the quiz review. So everyone have done, I will say everyone have done the quiz, and the quiz went also quite smoothly. Now, under the quiz midterm quiz section, I have also posted a feedback on the virtual teaching and learning environment. I would like your your help to give me more feedback so that I can try to improve the arrangement for the exam and also the project too. And if you have any good feedback, you can also let me know, because this is indeed supported by a grant from the UGC to improve the teaching and virtual learning environment. And in this course, we have used quite a bit of technology, and one of them is the e-quiz system that is used to conduct the quiz. Let me, without further ado, let me jump into the quiz first. So I am able to see the statistics of the quiz of the class. Okay, so let me check. So this is the statistics, and we have basically 6 questions. I can look at the facility index to tell what is the worst questions. Indeed, the question 4, the facility index, basically the average of the performance is about 52% only. So half of you cannot answer it correctly. So, but overall, for all the other questions, especially the last 2 questions, which require you to do quite a bit of calculations, you all perform quite well. Okay. Now let me go into each questions, and I will kind of explain some of the answers. But indeed, all the questions are randomized, so everyone may see a slightly different version of the question. In order to identify what is the question that I should really explain to you, I can indeed check which questions. Well, let me first go to the details and check. My internet connection is a bit slow for some reason. Okay. So here, this is the different variants of the same question. So the KDD question, there are 20 variants, and I can also see how many students attempted particular questions. The variants that is highlighted in red, they are well, their performance needs some attention. Okay, so I'm going to pick one of these to basically explain. So this one is attempted by 5 people, and the performance is not very high. So let me just focus on this one. So let me see if I can open it in a new window. Okay. Okay. So what is this question asking? So we want to identify the main knowledge discovery process for each of the following tasks. Choose none if none of the processes apply. Okay, so what are those processes? If you click on the drop-down menu, you will you will have a list of possible choices. Well, classification, cluster analysis, regression, association, rule mining. We have actually gone through classification in detail, and we will not go through regression, but then we will talk about cluster analysis today, and towards the end of the course, we will go through the association rule mining. I sort of only give you a brief overview in the first lecture, but if you have done some reading, then you would have more idea of what the process is about. Now, let me answer the first one. The first one, find out the highest score of a recent exam. I would say this is the tricky one. Is it regression, because we are trying to find the value of a continuous random variable. Okay, the score is indeed a continuous random variable. So if you have attempted this quiz, you know it is the score is it can be a fractions and have two numerical places. Now, so is this regression then? If I take regression and I check, okay, I will find that I didn't answer correctly. Okay, incorrect answer. Indeed, let me show also the mark and the maximum score. This is the instructor interface, so I can choose like how much to review to everyone. Indeed, I have chosen to review quite a bit of information because I think it will help you correct careless mistakes. Let me update the display and start again with this option. Okay, I think I just need to update the display. Okay, so this attracted a penalty of 0.2. Okay, notice if I check again, I still get the same penalty. It's not going to be accumulated if I don't change the choice. Okay, now if you think about it, why is it not regression? Can anyone tell me? Anyone have a choice? You can type into the chat. I can choose it and check whether it is correct. It is called lookup. Doesn't predict anything unseen. No need to train. Very good. So there's no training needed. All you need to do is just to look up. There's no prediction involved because it is not about predicting something you have not seen. Well, in the future, well, if it involves prediction, then it will deserve data mining. We mine the knowledge and try to predict things, but we are not predicting things. We are just looking things up. Very good. So the answer is none. Okay, and I should get the correct score. Okay, good. Now I have just now I have attracted a penalty of 0.2, and you can see the score here. And I repeatedly checked the same mistake, and it only deduct the 0.2 score. Okay, so I hope you are confident that I'm not lying to you about the deduction. But at the same time, don't rely on, don't optimize according to the penalty, because it might change. It is not necessarily 0.2 all the times. But if you take a look at this, the penalty is quite big, because the question is just to 0.4 mark, and if you answer, if you put in the incorrect choice once, it will deduct 50%. For multiple choice questions, the penalty is supposed to be has to be large indeed. Otherwise, even guessing will get you some score, which is not good. Okay, so the intention is it is trying to fix some careless mistake, and I hope you should be able to answer it with just 1 or 2 checks. Now, the second one, learn readers' interests based on their reading histories. Okay, so if you think about this, what do I mean by readers' interest? Well, if I ask the readers to fill in a survey and tell me their interest, then there's no prediction involved, right? So you just get information. But what is interesting is I need to learn it based not on a survey where there's readers fill in their interest, but based on their reading history. So I look at what they read, how much time they spend on reading what. I want to predict their interest. But what do I mean by interest? Do I mean a web page they are looking at? Is it discrete or not? Actually, the thought form, the interest, it is really more about a rule of thumb. So what kind of readers, if they read this page, then they would be more likely to read other related pages. So if you read, let's say, technology web page, the high-tech web page, then you might be more interested in like electronic gadgets or some other things. Then those pages will be your interest. So this is indeed what we call the association rule mining. Okay, so I don't bother to check. I think this is the correct answer. Now the second one, group image pixels of the same objects together. So what is it doing? Well, is it indeed classification? Well, I don't see any class here. I mean, I'm just grouping image pixels of the same object together. I don't know what object it is. It might be a piano, it might be a cat, and maybe a dog. I mean, I have no restriction of what it is. So there's no particular label associated with it. So this is indeed unsupervised learning. Now, grouping pixels, related pixels together, this is exactly what we are going to talk about. That is the cluster analysis, grouping similar things together. Okay. Now, is this association rule mining? Well, you might think, okay, we are trying to find out the association of the different image pixels. If they are related, then we group them together. Now, association rule focuses on the association. Okay, that is, how do we think things are similar? That is the rule to connect things. But cluster analysis focus more on the group of similar things. So just it is enough to return basically a group of related pixels, and you don't need to tell me, okay, why they are related or not. Okay, now the association rule mining is indeed much more general than finding similar things. Because rule can be in a more sophisticated form. So if let's say I want to study the behavior of buying stuff in supermarket, okay, how customer buys stuff in supermarket, I may have a conclusion that if someone buy beer, sorry, if a male customer buy diaper, then he is likely to buy beer. Why? Well, because a male customer who need to buy diaper because he has to take care of children probably, and he is probably asked by his wife to go out to buy stuff, and he is probably only getting this private time when he's going out to shop. And what would he do? He would go and get a beer to relax during his private time. Therefore, he would buy beer. Okay, that is the logic. This is the rule that association rule mining want to get. However, do you see any similar things? I mean, similar objects? Well, man is man who buy a diaper similar to a beer? Well, not really. Is diaper similar to beer? Also, not quite. Can you reverse the rule? That is, if a customer buy beer, can you tell whether he's a male? Maybe he's likely to be a male, but then can you tell for sure that he is indeed going to buy diaper? I mean, if you buy beer, probably it doesn't imply that you have to buy diaper. Okay, so this association is not even one direction. It's not even two direction. It's actually just one direction. So there's a lot of difference between the two. But again, this you would good understanding if you do some reading. Otherwise, this is actually quite confusing, can be confusing to you. So I would highly recommend you to do more readings in the required chapter. But I understand everyone has just limited time. So yeah, you will get to learn all this more later on because we are going to study these two very soon. Now, the next one, predict future demand for housing in the next 5 years. Obviously, there's a regression, right? So because house price is not discrete, it is a continuous variable, and we are trying to predict future demand. Okay, sorry, actually not price but demand. So, the demand, will there be a certain percent of increase in the housing demand and certain thing like this? If there are I mean, right now, unfortunately, people are leaving Hong Kong, so the demand probably will drop, and maybe the house price will drop. I don't know. Okay, now the next item, recognize handwritten digit. Oh, okay, so that is to recognize whether a digit is 1, 2, 3, 5, 4, 4, 5. So this part you have seen an example of a handwritten digit last tutorial, tutorial 7. Okay, that should be classification. Okay, so once I have filled in my answers, I can check again. Okay, and I can see that I only have penalty for the first part. So the penalty is self-contained. It's actually only specific to the particular part. Okay, of course, all this rule is subject to changes because the package running behind it allow the author to change anything. Change the way we customize and change the way we deduct marks and also give marks. Okay, but this is roughly what I would intend to do. Okay, so that is one question done. Any questions on this one? Okay. Okay, if not, then let me continue. Okay, so the next part is this, so the next question is the KDD step. So let me again open, sorry, actually this doesn't go into the variance. So let me show the details. Okay. Okay, now let's take a look at the red one. So there are a couple of them. I think the highly attempted one variant is this one. 6 of you have attempted this variant. Let me bring it up. Okay, so the question asks us to categorize each of the following by steps involved in knowledge discovery from databases. Choose none if none of these steps apply. Okay, the first one, identify densely connected clusters of neurons in the human brain. So this is obviously a cluster analysis. So let me look at the list. Not really. It doesn't show cluster analysis. What's wrong? Well, it is asking not the knowledge discovery process, but asking the step involved in the knowledge discovery. So the steps meaning, well, you go from the defining the problem all the way up to interpreting whether your trained model is good or not. So there are mainly four steps. Indeed, in the textbook, you will find many more steps, but then I would say it actually get a bit confusing when you try to divide things too finely. Even when I categorize things into 4 steps, some of you probably also find it confusing because some of the process seems to be related to preparation, but at the same time look like data mining and all that. Okay, so let me try to go through each of these. So right now, this is obviously a data mining step because I'm applying, well, I'm probably applying some clustering algorithm to cluster the connected neurons in the brain. Okay, so that is data mining. Now, what about the second one? Determine if more samples need to be collected to train a model for voice recognition. Okay, well, first of all, well, determine if more samples need to be collected. When you train voice recognition, what is happening? Well, you have a computer and sometimes, let's say when you want to have Siri, if you are using Mac, then you're dealing with a voice, an AI assistant called Siri, and then if you're using Windows, then that's Cortana or something. So they will listen to your voice and respond to you. And in order to recognize your voice, they would ask you to give them some sample, right? So they will record your voice and then do something. Okay, but the question is, if after you have given some samples, is it enough to recognize your voice? Well, it has to decide whether more samples is needed. Okay, And basically, it will have to do some evaluation to check whether the model is good enough to recognize the voice. So this is indeed the interpretation. Okay, so so whether the voice recognition can be deployed. Okay, so that is interpretation. Okay, now what about the next one? Reduce the image resolution to make training and prediction feasible. So this is often the case when you, let's say, want to, well, think about, okay, what about I want to classify images of cat and dog, okay? Then you will collect a lot of images. I mean, there are abundant images out there with cat and dog. You can Google cat, and then and there will be a lot of images. How do you train? Well, if the resolution is very high, then it will take a long time to train. So you also probably want to standardize the neural network to take only a certain number of pixels as input. So you will have to constrain the resolution, and reducing the image resolution, well, is basically a pre-processing of your data, right? So you have more pixels than enough. You want to pre-process it and reduce it. So this is data pre-processing. Okay, is that clear? Now, this is like also min-max normalization and stuff. Indeed, you will also perform min-max normalization on the image value, image pixel value. This is kind of standard to get things right. Okay, so okay, the next one. Advertise a newly proposed algorithm for image classification. Okay, is that interpretation? Well, we try to advertise a newly proposed algorithm. Well, let's say that is beyond deep learning or something. Okay, then can you say which one it is? Well, it is not interpretation because it is not about evaluating a particular model, trained model. It is about advertising, and that is indeed more about marketing, and it has nothing to do with data mining or knowledge discovery. Okay, so the answer is none. Finally, decide on what to learn from the human genome. Okay, well, we know that humans have human genome, and then we also have genome of different animals. The question is, if I want to learn something from the genome, I mean, what would that be? Is it more like, for example, how certain genetic disease might show up as some mutation of certain genes? Maybe autism can be attributed to the mutation of certain genes and something like that. But what do I want to learn? Okay, this decision is made in very early on, even before collecting data. And what is the step? Well, preparation. Okay, when you try to prepare your knowledge discovery, then you would have to decide the goal. Okay, so that is the idea. Okay, so that is any questions on this? Yeah, I don't know why it's quite slow. It is quite different on my Mac machine. So yeah. Okay, so everything is okay now. Let me go to the next page. Just check on my memory usage and see if I can kill some process. Oh, I see. Because I'm running a virtual machine. Let me kill that machine. I don't, I somehow I have virtual machine running. I don't know why. I couldn't quite kill it. Let's see. Yes. Okay. I will continue to see if it will get better. It is still using up quite a bit of resources. So let me continue with the next question. Okay. So the next one is the precision and recall. Okay. So indeed, you guys do very well. It is also quite straightforward. Let me just bring up one version. I think any version is fine. Okay, so what this question is asking is, given a confusion matrix below, we want to compute and identify the following evaluation metrics. What are the metrics? Well, you have to also fill in the metrics. So the question is, given a patient is tested positive, what is the chance he or she actually has the disease? Now, before I talk about the metrics, let's talk about the value. So when we ask, okay, well, when a patient is tested positive, then I'm looking at the first column that is predicted positive in this confusion matrix. Then the chance he actually has the disease, well, that is what is the probability, what is the fraction of actual positive out of all the predicted positive. So you will sum up the two numbers in the first column as the denominator. So you will have 7 divided by the sum of 7 and 5, that is 12. Okay, so that should work. Ah, 7 divided by 12. Okay, good. Yep. And what is the metric? The metric is precision. Okay, so that's how it is called, but another name is positive predictive value. Now, the second part, given a patient has the disease, what is the chance he or she is tested positive? Okay, so given he had the disease, so I'm looking at the first row. Okay, and I would like to know what is the fraction of predicted positive out of all the actual positive. That would be 7 divided by 7 plus 4. So I can write like this. Now, I don't really need to do the addition in my head. If I don't want to, I can just write it like this. Okay, so that should check. Good. I see. Fine. Okay. Okay. So now, okay, so that's a question, sorry. So the actual data collection from other sources fall into preparation as well. Yes, so if you are trying to collect data, let's say actually preparation is like all the steps before you actually finalize your data set and all that for training, for pre-processing. Pre-processing is more so I think what could be confusing is preparation versus pre-processing. Okay, pre-processing actually is more technical. And you would apply, let's say, dimension reduction techniques that is quite standard, like PCA or PCA or something like min-max normalization and all that to well, reduce resolutions and all that to apply to the data. But then before the data is formed, you will have to decide, for example, what information to collect, what kind of survey to give, and can you get information from different sources and merge them together into the data set you want to use to train. So these are more non-technical, and it involves well, I would say involve personal decisions. So you have to decide on what to do. Defining the goal of what to learn, I mean, that is also involved in preparation. So preparation basically are more non-technical. Okay. Okay, so if you have any follow-up questions, feel free to send to the chat. Now, let me go to the next question now. The next one is F-score. Okay, so this question is more problematic. So only 52% facility index. So let me look at the, yeah, actually, it probably doesn't matter which variant I use. Let me just choose one of them. Because the main thing is probably about how to compute it. Okay, so what this question is asking is consider the data D below with nominal input attribute x1, x2, and y. All of them are binary. Okay, either value 0 or 1. And the target is y. Okay. Okay. Calculate the following quantities on the. Sorry. Somehow this is not the right question. I clicked it. Yeah, well, never mind. Let's just stick with this one. I mean, because my computer is a bit slow today. Let me just stick with whatever it gives me. Okay, so info of D. I want to calculate the info of D. What is that? I would look at the class distribution of the entire data set. So I see how many ones are there, how many zeros are there. Well, I have 4 ones and 2 zeros. So what is the distribution? The distribution will look something like this: 2 divided by 6, and then 4 divided by 6. Okay, this is the class distribution. But in order to compute the info of D, I would have to look at the entropy of this distribution. And you can use this entropy function H to compute the entropy. So I can just put it like this, and I can check to see if it is correct. Okay, yes, that is correct. Of course, if you want, you can also use the formula log base 2, but it will take you more time. Okay, so knowing that you can use this entropy function H should save you quite a bit of time. Of course, this H is not always available. If it is available, I will tell you, for example, the Gini index. If it is available, I will tell you how to use it in the question. It is not by default that you can use it. Okay, same for log 2. Indeed, you would. I mean, I will put it here if you can use it. By default, the questions run something called the maxima. If you want to know about maximas, you can look at some of the functions available, like exponentiation is CXP, log is natural logarithm is LOG. In this course, I often use LOG for the base 2 logarithm. And that is indeed, I inherited from information theory because information theory mostly deal with bits. And we, instead of always writing 2 there, we kind of skip it. But unfortunately, maxima doesn't follow that convention, and you have to use log 2 for log base 2s. Of course, if this function is not available, you can always just do this division and get the log base 2. Okay, so now the next one, info x1 of D. Now, for info x1 of D, I need to divide the data into 2 parts. One is when x1 is equal to 1, and the other is when x1 equal to 0. So let's look at the first case, when the data is equal to 0. Okay, so when the x1 is, sorry, and when x1 is equal to 0, what is the class distribution? It's 1/3, 2/3. So I would put something like entropy of 1/3, okay, 2/3 here. But then I have another one that is, so actually I would put a weighted sum. So the weight is basically the fraction of instances with x1 equal to 0. So that is 3 out of 6. 3 out of 6. Okay, now the other part of this is the entropy of the class when x1 is equal to 1. So that let's look at the class distribution. Again, 1/3, 2/3. Okay, so again I would have 1/3, 2/3. Then actually I don't need to put a weighted sum, but for clarity, let me just put it in. Even though the both sides are the same. Okay, 3/6. You will also have this. Okay. Again, you don't need to simplify your answer. You can check it now to make sure it is correct. Okay, so I have 2 checks. Okay, although it says that my answer is partially correct, it doesn't mean it penalized me on not filling in the blanks below. It sometimes you can check your answer progressively, just like this one. Sometimes not. Well, because sometimes I mean it's up to me to decide based on the question type whether progressive check is appropriate or not. But most of the time I will allow progressive checking. So the next one is info of x2. But before I answer this, maybe I answer this one. So this is more meaningful. I look at the gain of x1 divided by the split info of x1. So what is the gain of x1? You can just copy and paste here. I mean, it's info of d. Okay, so let me put a parenthesis here first. Info of d minus the info x1 of d. Okay. Next, I have to divide it by the split information. What is split information of x1? Basically, I look at the distribution of x1 and compute its entropy. So how many ones and how many zeros I have for x1? I have 3 out of 6 equal to 0, 3 out of 6 equal to 1. So this half-half. So it's just entropy of 1/2, 1/2. That's it. But indeed, this is just equal to 1, so it doesn't really matter. There's no indeed no need to put it in. This denominator, you don't have to put it in because it's equal to 1. Okay, so I get it wrong. So let me see what is wrong. Info of d minus this divided by yes, so that's a problem because of this addition here. When I put a minus, unfortunately, this copy and paste don't change this sign for me. So I have to put it in. Okay, so that's a careless mistake, and exactly what this check is trying to avoid. Okay, now the penalty. Let me just submit it to show you the penalty. Okay, the penalty well, I didn't. Okay, it doesn't show the mark. Yeah. So this preview get reset. So I have a penalty of 10%. So I lost 0.1 for that particular part. Okay. So this penalty is much smaller than the multiple choice, but still not that small. So don't guess the value. Try to get it right the second time at least. Okay. So that is good. Okay. So I hope my explanation here is useful for you, especially for preparation for preparing for the final examination. Again, if there's anything you don't like, let me know. I hope to have the check for you guys to use. But if this is something you don't like, you can also tell me to disable it. But I guess this is a feature that everyone would like to have. Now, let me continue to the next one. That is the F score. Okay, so let me use this one now. Okay, so what is this asking? Given the F score of a classifier is 7 out of 9, what are the minimum and maximum possible values of the precision and recall of the classifier? Okay, this is actually what I also mentioned in the lecture. So if you have heard my lecture, then and also answers the questions in the slides, then you probably understand what this question is about. Now, to calculate it for the particular value here, then you would have to do some algebraic manipulation. Okay, so I am going to write it here. So what is the definition of F score? F score is nothing but the harmonic mean of precision and recall, and precision is PPV. Recall is true positive rate. Okay, and the harmonic mean is taking the reciprocal, take the average, and then take the reciprocal again. Okay, now what is the question saying? Well, I want to know the minimum and maximum possible value given a particular F score, right? So let's just look at the PPV first, because by symmetry, the PPV and the true TPV will have the same minimum and maximum possible values. Okay, so what should I do? I should then think about how to bound this inequality. I know that PPV and TPV, TPR, they are all between 0 and 1 because they are, well, they are like probabilities. Okay. Therefore, I can, let's say, if I want to just solve for PPV, I can put an inequality here. Well, first of all, harmonic mean is kind of non-increasing, not non-decreasing with respect to this value. Meaning if I, let's say, change this TPV, TPR equal to 1, so I get PPV inverse plus 1. Okay, I change it to 1, which is the largest possible value here. Should I put less than or bigger than? Anyone can tell me? Should I put less than or bigger than here? I'm putting in the largest possible value. Well, actually, without knowing the F score, the largest possible value of TPR is equal to 1. So if I put it in a formula, it will, of course, bound the F here, but is it an upper bound or a lower bound? Can anyone type in the chat to show what it should be? Okay, so the hint is very good, less than, because the hint is indeed that less than equal to, the hint is that F score is proportional. It is actually non-decreasing. That is increasing in the argument. It makes sense because the higher the true positive rate, the higher the F score. I mean, it's measuring performance. But it may not be obvious when you look at this inverse here. But this inverse, there's another inverse there. So because of that, is non-increasing. Sorry, non-decreasing. Okay. So now I have this expression F score is smaller than, so just forget about this part for now. Don't look at it. So I will manipulate this. So I will have F inverse is now bigger than or equal to PPV inverse plus 1 divided by 2. Then I can move it over. I will have basically 2 here. And then I can subtract 1 from it. Okay, and I can take the inverse again. So I will get, now when I do this, whenever I take inverse, I need to reverse the inequality. So I actually have a minimum value for PPV. So PPV would be at least this much. Okay. Very good. So then I am going to plug in this formula. 1 divided by 2 and then f inverse. So just 2 divided by f and then minus 1. Okay, let's do that. The minimum possible value is 2 divided by f. So that is 7 divided by 9. Okay, and minus 1. Okay, I hope this is clear. And let me check. Okay, I got it right. Now, what about the maximum value? Well, I can do something similar. Okay, instead of substituting 1, I can substitute 0, right? So all I need to do is now put a 0 there, then the sign will be reversed. Okay, and now I do it this way. So I solve for it. Okay, I will then take the inverse here. So f inverse and then multiply by 2 as well. But instead of subtract by 1, I subtract by 0. I then take 1 over that. Okay. So is that good? Okay. So I also have the reverse inequality here. Okay. So 1 over 2 and then f inverse. Okay. Okay, 1 over 2 and then f inverse. That is 7 divided by 9. Okay, so let's check. Something is wrong. It doesn't work. What is not working? Can I do something like this? So simple. Oh, can I turn it to a floating point number? Okay. Not good. Simplify it first. Oh, okay. So that will show me. What is this value? So can anyone tell me what went wrong? So is that right? What is this equal to? So let me see. Yeah, the maximum is equal to 1. But what went wrong with this substitution? So we cannot simply plug in the value of 0 or 1 into the equation. So the minimum possible TPL is not equal to 0. So by symmetry, the minimum are the same. So what is actually wrong? I probably just forgot to put the inverse there. So remember, this is the true positive rate inverse, and it is right that I just cannot plug in 0 there, because why? That would be division by 0, isn't it? So what does it actually mean when I divide by 0 there? Well, this will go almost like infinity. Well, imagine you take the limit when true positive rate goes very, very small. What do you get? The inverse is like close to infinity. And this, how do you take average of infinity with something to get something that is finite? Well, you can't. Okay. Indeed, anything you put in here, whatever you put in here, infinity will be infinity. Well, unless this is also infinity. I mean, but you can't have infinity there. I mean, the point is the smallest value 0, even when true positive rate is infinity, you can't have. Well, actually, the smallest one is 1. The inverse, the smallest value of the inverse is equal to 1. 1 plus infinity divided by 2, that gives you infinity. And then take the inverse of that, that gives you 0. Okay, and the F score would be 0. Okay, so you can't put in true positive rate equal to 0, because if you have that, then immediately the F score would be 0 and it cannot be equal to 7/9. Very good. So what does that actually mean? It would be a lot easier if you remember the plot I put in one of the lecture. That is the contour plot of the true positive rate and the precision. And every contour corresponds to the same value of f. So for example, f equal to 0.1 will be here, and all the way up to here 1. Okay, f equal to 1, f equal to 0.9, and so forth. Okay, so you will find that, okay, although once you specify a particular value of the F score, okay, you can talk about what is the minimum possible PPV. So you project it to the, well, you walk along the contour until you hit the, to hit the boundary, then you get the smallest possible value of PPV. But what's the largest possible value of PPV? Well, you continue to go in the other direction and you get the largest possible value is 1. Well, if you can continue to walk along it, if you choose true positive rate equal to the smallest possible, that is, sorry, I should reverse the axis. So I'm confusing you guys because it is the other way, true positive rate, and then the PPV. Okay, the smallest minimum value of PPV is this one. This is the minimum value. But then what about the maximum? So minimum value corresponds to the case when true positive rate is equal to 1. But if you continue to walk in the other direction, okay, you can't get TP out to 0 because in order for it to go to 0, then the PPV has to go to infinity for that particular value of f. Okay, so the best you can do is to get to this particular value, that is f, that is when PPV is equal to 1. Okay, so all in all, this is less computation, but more about understanding why people use F score and also the plot of this. Okay, so this will give the correct answer. Good. It is a bit tricky. But then, yes, we don't try to trap you. I mean, this question is really asking your understanding of harmonic mean, why people use harmonic mean. Okay, good. Now, any questions? And now, finally, the question on FOIL game, and then we will take a break after this. Let's look at the variance. Okay, so FOIL gain is poorer than info gain. So I guess it's probably not as intuitive. I don't know why this is more difficult to you guys. So let's take a look at the one that is not performing well. So I think here, okay. So again, it actually doesn't matter because it's more like a different. I mean, just different data set. I mean, I randomly generate the data set and also check the solution until it is doable. Now let's take a look at this. So the question is, consider the data D below with again binary attributes, and Y is the target as well. We want to calculate the FOIL gain respectively for adding each of the following conjuncts to the rule Y equals 0. Okay, so what we are looking at now here, if you add x1 equals 0 to the conjunct, then what is the FOIL gain for the rule? So what we are talking about, so let me use the, let me show this. Okay. Okay, so what we are talking about is this rule, starting from here to, starting from the rule without any antecedent, I go to this rule. Okay, now in order to do this, and I would need to calculate. Can I just copy this? Okay, let me just copy the data. 0 0 1 0 1 1 1 1 1 1 0 0 0 1 and 1 0 0. Okay, so the first thing I would like to do is to calculate the number of positive and number of negative, also the number of positive prime and number of negative prime of the new rule. So for the original one, I just look at the last column. It's to calculate how many positives are there. There's 3 here, and also 3 for the negatives. Okay, now what about when I add the conjunct x1 equal to 0? I will have to identify the covered instances. So that's just one here. So if that is the case, the number of positive equal 1, number of negative equal to 0. Then I apply the FOIL gain formula, that is p prime times log of p divided by p prime, p prime divided by p prime plus m prime minus log of p divided by p plus n. Okay, I actually realized that the notation I use is a bit confusing. That is, this n sometimes is used to represent the total number of data points, and sometimes it is represented, well, in this case, it's representing only the number of negatives. Okay, but well, I probably don't know how to fix. I mean, we only have a limited number of alphabets, so unfortunately, you have to stick with this ambiguity. Now, if I just apply the rule, then that would be 1 times, okay, 1 divided by, 3 divided by, log of 1 divided by 1, and minus log of 3 divided by 6. 1 divided by 1, that gives you 0. That's a log of 1. Again, all these are log base 2 because the unit is bits. FOIL gain is also measured in terms of bits. Now, this one is log of 1/2, indeed just minus 1. So minus that gives you a plus, and you get a positive gain of 1. Okay, so this is gain of 1. I can check to see if I'm doing okay. Yes, I'm doing quite okay. Now, the next one, when x1 is equal to 1, then what do I get? Well, I need to also, let me just make the change here. Well, indeed, if you are doing it faster, let me know the answer. I can use your answer right away. Otherwise, I'll just continue to do this one. So when x1 is equal to 1, now I need to highlight the other one. That is when x1 equal to 1. So these are the 2 covered instances. Okay, and all I need to modify is these two counts, so that is 1 1. Okay, so instead of 1 over 1 here, I would have 1 over 2 over 2, and I would also have 1 here. It's the same as before. So this one, instead of 1, it will be minus 1. So minus 1 plus 1, I don't have any gain. Okay. Well, intuitively, you can actually look at it, eyeball it. Originally, the class distribution is half-half. And after you have confined it to these two, the class distribution is also half-half. Okay. But of course, this only give you a rough intuition. You have also this term that would put a weight on the amount of coverage. And, as I mentioned in the lecture. Now, 0 is the gain. So let me put it and check. Oh, something is wrong. What is wrong? I made a mistake. Why did I put? I actually forgot about this instance. Okay, very good. Yeah. So this check indeed is so important. I would say even I made mistake here. Yeah, this is something I like to have in the exam. So I need to update the count. So the count is 1 and then 2 zeros. 1 1 and then 2 zeros. So not as good as I think. So actually now the gain would be negative. Okay. And I don't want to calculate this logarithm, so I'm going to just put it directly. So log base 2 of 3, the negative of that, negative log base 2 of 3, and then I would plus 1 to it. Oh, okay, I shouldn't put it here. I should put it there. So this should give me a kind of negative 0.58 something. Okay, okay, sorry, still wrong. What is wrong? Let me see. How come I miscounted this? So there are 2 1s here. I don't know why I make so many mistakes. Yeah, when x1 is equal to 1, what am I looking at? I miss all this. Sorry, guys. This is another mistake. So I should really label the columns. So here, number of positive is 2, but the number of negatives is 3. Okay, finally I can probably get it right. I would have, okay, I would have 2 times 2 divided by 3. Two divided by 3, put the negative sign, 2 times that. Why is it still wrong? 2 over 5? 2 over 5, yes, sorry. Yeah, I'm making so many mistakes now. Okay, that should be 2 over 5 because I should count both the positive and negative. Okay, finally I get it right. Okay, thank you for the fix. So I guess I don't have to go through the other side. You can do it on your own and get it right. No wonder this question is it has so many penalty. Yeah, I would say sometimes probably the numbers is more difficult. But yeah, so it's just addition and subtraction. I forgot to get all the other examples, and also forgot the sum here. Okay, good. I learned from our mistake, and hopefully next time I don't make it again. So let's see let's check on time. I will have a 5 minutes break. Afterwards, I will talk about the project two release. Okay, so 5 minutes break. You can actually also open the project two to take a look at the description there. So it is under your under the same sections for this week. Okay, that is here. Here, project two, and once you open it, you will see this. Okay. So 5 minutes. So let's come back at 8. Um, let's make it 8:15. Okay, let's get started for the second part of the lecture. Okay. One of you has sent me a solution to the F-score problem, and I think it looks also very clear to me. This may be even better. So let's take a look at this. So what the students did is it expressed the true positive rate and the precision in terms of the four quantities in the confusion matrix. That is the true positive, false negative, and all that. And then you substitute it to the formula for the F-score. So you get this value, okay? And then you can say under what situation the true positive rate is maximum. It is maximum when the false negative is equal to 0, and then you will get the value that is maximum is equal to 1 and all that. Okay, so you can try to follow this logic as well to attempt that question. Okay, very nice. Now, okay, so now let's take a look at actually before I talk about the project, let me also mention two things about the tutorial submission today. For tutorial 6, I think there was some miscommunication on my side. So the grader didn't know the deadline for tutorial 6 has been extended to today. So and some of the assignment was graded. In order to avoid leaking the solution, I erased the feedback and everything. So even like if you have submitted before your submission, record will also be erased. So please make sure you resubmit again for tutorial 6. For tutorial 7, that's okay if you have submitted. That is also in something called the exchange server. Actually, the way things work is that there is an exchange server who is handling submission, and then we will also collect a notebook from the exchange server. Now, when I erase the record in the exchange server, then you need to submit again in order for us to collect. So that is so exchange server is really the place for exchanging submissions and collection and grade and feedback. So yes, so please make sure you resubmit again for tutorial 6, even if you have submitted before. For tutorial 7, there is a typo I have introduced, and thanks to one of you who pointed out. For the last exercise, there are 2 answer cells. This you can safely ignore it. The second one, it doesn't do anything. I mean, other than throwing a not implemented error. If you want, you can comment out the not implemented error. It's not going to affect your grade. Now, you should not delete it. I mean, if you delete it, then the auto grading will fail. So if you accidentally deleted it, please fetch your notebook again from the server and copy your answer over. This is also what we are going to do if the auto grading fails. So if you really don't know how to do it, then we will try to handle it as well. Okay, so so that is about the tutorial submission today. Now let me go into the project. So for project 2, what are you supposed to do? Okay, what should you submit? So there are quite a bit of details. So before I talk about what you submit, let me first talk about the requirements. Okay, so what are the requirements for project 2? So your group should choose a topic that involves the following elements. So for it to qualify as a project in data science, it should have a data set that is associated with a real-world problem. And how do you find the data set? There are some resources you can use. For example, here, you can use the challenge data website. You can use the Kaggle website, UCI machine learning repository, and also OpenML. There are abundant real-world data sets. So choose one. I think it would now involve your I mean, this is indeed the preparation step when you try to identify the problem you want to study and also select the appropriate data set. Of course, you don't need to go out and collect your own data. If you want, you can do that, but that is probably going to take too much time. The second one is to apply some data processing to prepare the data for mining. So once you have settled down on what to learn and also what data set you want to use, you might probably have to apply some normalization, fill in some missing values and all those pre-processing to make the data work. And you can apply data mining algorithm to that data. I would say that quite a lot of data sets are already very clean, but of course, you are graded on your skill. Therefore, if you obtain a very easy data, then you would also show less. I mean, you will basically may score lower in terms of the technical element. I will talk about the rubrics very soon. Now, the third one, a learning algorithm that extracts knowledge from data. So of course, that deserves, I mean, the attention here. That is, you probably want to apply a classification algorithm, clustering algorithm, or association rule mining algorithm. But if you want, you can also use a regression algorithm, something that we didn't talk about in class. But indeed, a lot of classification method can extend to regression. So you are learning the theory, but it's just changing it in a different form. You get regression, and the evaluation metrics would also be slightly different, but not too much different. Finally, you also need evaluation of the mind knowledge that is showing your interpretation. So is the quality of the mind knowledge good enough? If not, why? If yes, that would be nice. Congratulations, then you get a very good score. Okay, now the next one. It is your responsibility to identify a relevant topic and take proper measures to avoid plagiarism. Now, don't use projects from another course and put it directly to this course. This is called self-plagiarism. Now, however, what is okay is if you want to do a competition. So there are many data challenge competitions out there. If you want to do it concurrently with this project, that is okay. Indeed, I think if you win an award or get a very high rank, let me know that this is something that we want to keep track of to showcase our students. The next one is while you are well, sorry for the typo. So you can use Weka to complete the project, but you are also free to use other tools. Okay, beyond what I teach. Indeed, this project is quite open-ended, and learning something beyond what I teach you in the course is indeed highly encouraged and highly recommended, because I only can teach you as the surface. I mean, I only scratch the surface of data science, and in order to go deep, it would be great if you can explore more techniques and show me that you have a good grasp of the basics that allow you to go deeper. And so that said, you can definitely apply a deep learning technique you have learned from your deep learning course or some other sources if you want. Deep learning doesn't apply to everything, but if you consider image processing, maybe that's a good choice. So how are the project assessed? Okay, we assess it on 5 criteria, and each criteria have 3 points to it. So altogether, there will be 15 points, and they contribute towards the 15% of the entire course assessment. Okay, now what are these categories? The first one is the project score, report score. So it is well, you would have to actually submit a report. So in certain format I will talk about, and then that counts toward this. Okay, there are some questions for you to look at when writing a report. So for example, is it clearly written with the correct structure? Are there proper citations? Are there enough citations? Okay. The other one is whether it is possible for other people to reproduce your results. Okay. Often the report in static format doesn't quite allow other people to reproduce your result. So I would actually recommend the use of Jupyter Notebook, just like what I use in class, in the tutorial. You can run the code and check for yourself the result. Now, I will talk about it soon because I have built a demo, a template. If you want to use, you have free to use the template for project as well. Now, the second one, presentation score. So remember that you need to do a presentation in one of the 2 days. So actually, we have scheduled earlier. And you can look at the group presentation section in the course homepage to check the schedule. Okay, we will check whether you have formulated the problem well and motivated well. Sometimes I think indeed most often the case presentation are hard to follow because the problem is not clearly defined and motivated. So the question is, why do you want to mine the knowledge? So this is really related to the preparation step. Is there a proper use of visualization techniques to convey the results? Many slides are mostly text information. Although text is easy to type, it doesn't show things as clearly. Okay, I mean, I would like you to, describe the data using appropriate tools. I mean, we have many plots like scatter plots, histograms, and all that to demonstrate the distribution of the data and also even the clusters and all that. So try to visualize it. Of course, for very high dimensional data, it is hard to visualize things, and you may consider, let's say, tables, using a table to present the result and all that. Okay. Now, our questions from the audience also addressed well. So there will be Q&A at the end of the your presentation. Then you will also be assessed on whether you can address the questions well. Okay. So instead of being overly defensive to say okay, the questions doesn't make sense or something like that. Okay, try to address it well. Try to understand what the audience is asking you, instead of saying that I just don't understand what you are saying. Okay, so something like this will help. The next category is the correctness score. So this will be will also depend on how you address the questions. So if you fail to address certain questions, it might reflect that there's some mistakes in your analysis, and make sure that you correct it. Indeed, you have a chance to correct it because the project submission is after your presentation, and you are allowed to incorporate what you have learned from the audience to change your report. Okay. Are the results correct, and also are the learning process and evaluation method appropriate, leading to correct results? Okay, so this is very important because, for example, overfitting can give you overly optimistic score. You want to avoid that with, with the proper techniques we have learned in class. Okay, the next one is the technical element score. So this is about how sophisticated techniques you use. Again, it is okay for you to apply what you have learned beyond the class. Indeed, you can get a high score if you use more sophisticated techniques. Is the quality of the mind knowledge better than existing one? Okay, so if you indeed find a better way to diagnose diabetes or autism, you get you have a better, well, you introduce a new algorithm to mine knowledge, or those that is related to the technical element scores. Of course, the ultimate goal is, well, the highest rank would be for work that are publishable, that you can indeed publish in a conference or a journal paper. The next one is, are there meaningful generalizations to related classes of problems? Okay, so if your techniques is very, very specific to the data set you are using in particular, then the application is kind of limited. But then if you have a general approach, a new algorithm that would apply to different data set, then of course this is going to be to give you a higher score. Finally, team spirit, 3 points. It is quite an important category. It is more about how you manage your team, whether you can successfully challenge others during the presentation. Indeed, during the presentation, I will keep track of who asks what questions. And if you ask more questions, you represent your team to challenge other teams. And if the challenge is successful, that is, the other teams indeed find that your questions is cannot be easily addressed by the method, then you win. You get a higher score for the team spirit. Can the team members work together efficiently? I mean, if there's argument during the work, and if I know about that, then this will also lower the score. But of course, I will try my best to help resolve issues, and try to make it fair for the contributions. I mean, I will give marks. I will give the same score for all students in the same group by default. But if there are arguments, there are free riders, I will change it. Okay, I will address free rider problem. But of course, I hope it doesn't happen. The final question is, is the workload evenly divided among members? That's actually what I just mentioned. Okay, so are there any questions on this? If not, then I will talk about what to submit. Okay, so this is actually an assignment where you can submit. So this is the instructor interface for you. You should be able to submit through this page. Now, what do I expect? Of course, you can just do things the traditional way. You write a PDF file report, and the report roughly 15 pages. I mean, this is just a rough idea, so don't worry too much about font size and everything. Try to squeeze everything in 15 pages. That's not the intention. This is just telling you roughly how much work I expect from you. Now, this project, you can do it as PDF and submit it, and you will also need to submit your presentation slides. If you want to use PowerPoint, then you can submit the PPT file. You can also use PDF as well. And then if you have source code, you can also submit it as a zip file or some other format that is that you prefer. Okay, so that's actually very little constraint on what format you should do any of this in. Okay, but I would recommend you something. I mean, if you want to make your code reproducible and everything, also allow other people to work together, then I would recommend using Jupyter Notebooks and also the Git version control. Okay, I think from the feedback from the limited feedback survey from you guys, I think the majority of you, actually 2 out of 3 of you, like to use Git repository. Okay, but I hope more of you can respond to my survey, so I get a better sense of what is going on. The survey is anonymous. So if you provide a feedback, I don't know who you are, but if you want to make it named, you can also email me directly if you don't mind. Okay, so I think Git is a valuable knowledge to use, but it does take you some time to read and understand what it is. Okay, you can of course go to the Git version control documentations to read it. There are also linking Linda CTU. There are online courses you can watch for free. Linda.com or some. I think it might have changed to LinkedIn Learning or something. So you can check. So there are a lot of courses teaching you how to use Git. Now I have also set up a GitLab server, just like GitHub server, for our students to use. So in particular, I have actually put a demo report on that server. So if you click on this link, you will open the demo report. So you can actually use this as your template, and you can create a Git repository on the GitLab server we set up. Okay, so what this is right now, it is actually telling you how to use this as a template. So so right now there are the important sections, just like a report. You would have introduction, preliminary, and also references. If you go to the references part, and you can see the two textbooks that we are using for this course. Okay, all this you can actually do it using Jupyter notebooks. So this is actually the same engine we use for the tutorial notebooks. It is compiled using the Jupyter book. Indeed, this can be done automatically once you have created the necessary configuration. You can use the GitLab pages functions to create all this. So for now, let me just demonstrate what this is. So if you go to the preliminary sections, okay, then you will find some link. One of the link is to the link to this book. The other one is the link to the GitLab repository. So if you click on that one, you will see our GitLab page. This is the GitLab server we're using, the gitlab1.cs.cdu.edu.hk. And you can also see all the code that is used to compile the book. The book is compiled automatically using the continuous integration and continuous deployment. Okay, indeed, you can just copy this notebook, this repository to your project repository, and it will save you a lot of time setting things up. Okay, so what this is doing is under the documentation folder, sorry, docs folder, you will see the Jupyter notebook there, the abstract, build, content, and also the references. Okay, and this is what get compiled into the book here. Okay, so the next thing is actually that if you can actually run the notebook by launching it to our Jupyter Hub server. Okay, so you can click on this launch link here, and once you do that, it will open the notebooks onto our Jupyter Hub server. Okay, that means you can use our server to build your notebook. So our server has already installed the TensorFlow and PyTorch if you want to use deep learning, and there's also GPU resources you can use. Okay, and well, indeed, there are quite a lot of libraries you can use based on, the tutorial notebook. You can use Weka, you can use well, you can use the sklearn. Yeah, so all these tools, it is actually quite difficult for you to set up your own Jupyter environment or Python environment to do stuff. So this may be a time saver, so you don't need to install anything, and you can directly use the resources here. Okay, of course, you should not use my repository. I mean, you can't change my repository. If you want to use this as a template, you should learn to create a new repository and put in your code. And after you put in your code, you can also invite others to join in. Okay, now how do you do that? Well, you can go to the homepage, the GitLab 1 page, and there you will have an option to sign in using your CTU account. So you can actually use your CTU EID to log in. Okay, take some time. It will redirect you to the CTU login. Okay, I don't know why. Yeah, I think my computer isn't working properly. Yeah, so I'll do it later then. Yeah, because earlier, just a moment ago, I am able to log in. Okay, so anyway, you can run it, and then well, you can log in with your CTU ID, and then you should be able to create a repository and also fork the repository that I'm using here. So you can easily clone the template repository into your own work. Okay, into your own repository. Okay, so let me see. Okay, so now if you do it this way, then I will be able to easily check your results, reproduce it. This is indeed very good for me to do the grading. And I would like you to put it in this format, but if you cannot do it this way, I mean, you can also try other ways. So of course, you can also install your own setup. But then the question is, for me to reproduce your setup, I need to also know how you install things. Indeed, the way to do it, proper way to do it is to write something like a Docker file showing how the system is installed, and then push the Docker image up there to the Docker hub. This is actually done for the CS5483 Jupyter server. So this I can launch it in a public service called the binder service, and sometimes it refuses to run it because I got lucky. I get the resources. So this is a public. You can think of it as a public server that allows you to build another server. That is what we call a container, and to run different things. And I have basically built a container for the Jupyter server. Indeed, everyone, when you log into the Jupyter Hub server and run code, it is running in a container. And this is also done here. And I can I have actually pushed the Docker image, so you can run it anywhere. Indeed, run it in Binder. You can also run it locally on your computer. So, for example, here, if you go back to the book, okay, under this preliminary page, towards the end, you can download the Docker container and run it locally on your computer. The way to do it is you install Docker, install VS Code, and also the remote container extension. And once you do that, you can open the repository and launch the Jupyter Hub server locally. So it will be the same way as you basically use our Jupyter Hub server. You can run the same notebook locally on your computers using the same environment. without setting up your environment. Okay, so this is actually nowadays very popular solutions for companies, and many companies are using Docker images container technology for the developer to develop code. So if you're interested, you can also learn about Docker and building those Docker images and push it to Docker Hub, and then allow other people to run your setup. Okay, but for using this template, you don't really need to run anything locally on your computer. You can just push it, or you can just launch everything onto our server. Okay. Okay, so that is about project 2. This is the template. Now, there's also an alternative to PPT. So by the way, so if you are doing things on the GitLab repository, then there's no need to submit the reports in other formats. So all you need to do is to submit the link to your repository. You still need to submit, and by the deadline, you should submit the link to your repository. But your repository is actually a detailed record of all your work, including the book you compiled there. But of course, if you use the Git repository but do not compile the book, then you should submit a report separately onto this assignment page. And also, you can use a plugin called Rise plugin that would actually allow Jupyter Notebook to be presented as slides. So that way, you don't even need to build your PowerPoint slides or PDF, and you can just show the Jupyter cell directly. Again, it takes a bit of time to learn to do those stuff. It may actually take you more time than just use PPT. In this course, I actually do not have enough time to build the slides from in the Jupyter Notebook. I just use PPT. But for the other course, like CS5483, the introduction to Python programming, I use Rise to present, and it works quite well. So if that is the case, you don't even need to submit any PowerPoint slides. I would accept, I mean, that you are just using the Jupyter Notebook to present. Okay, now optionally, you can actually pre-record your video and submit to me. The reason why is it actually during the onset of the political turbulence in Hong Kong and also the COVID issue. My previous offering of this course went online, and students actually have to submit video recording to their projects. But what I found is that the video recording, some of it has very high quality. So I think it is actually a good idea. If you make a video recording, then I can showcase it to other people. So it's up to you. If you want to create a video recording, you can actually play the video recording during your presentation section. And you don't need to worry too much about public speaking issues. You also don't need to worry too much about the time limit. Okay, you will have a hard time limit. I will stop you when time is up, so make sure you don't overrun. Okay, so everyone would have 15 minutes to present and 5 minutes for Q&A. Now, okay, so I think that is all about project 2. Are there any questions on this? Oh, the group presentation section. So let me take a look at the (13). So the presentation schedule, yeah, I think should change this to 2022. Okay. Okay, so just changed it. Sorry for the mistakes on the year again. Okay. So let me double check the presentation date should be April 13th. Yes. Okay. Good. Any other questions? I am going to give you another break now. So 5 minutes break. Actually, let's make it 8 minutes break. So we will start at 9 p.m. and then we will talk about clustering. Meanwhile, if you have any questions, feel free to send me a chat message. Let me see. Your group is section 2. Did I make a mistake? So yeah, what is your group number? 4. Okay, so I'm going to double check and I will let you know after the break. Okay, so welcome back to the last part of the lecture. I have, so for the presentation, I don't know why I'm not aware of the group 4's reservation. Sorry about that. I have reassigned the group 4. So to the evening section. So what it actually means is that we will just have more groups in the evening. Now, if you would like to move from evening to afternoon sections, let me know. The other way probably is not a good idea because then it will be too imbalanced. Okay, so if any group would like to move from evening sections to the afternoon section, let me know. Otherwise, we will just have more groups in the evening section. Okay. With that said, let me start. And by the way, you can take a look at the instructions about the group presentation under week 13. Okay, for the lecture today, we are going to go through clustering. So you can open this PowerPoint slide. Okay. Okay. We are going to talk about partitioning methods today. Let's motivate the problem again with a simple example. So let's look at the data set on the left-hand side. Can you find similar tuples together? So I'm calling every row as a tuple. Now, what are similar tuples? How could we group them together? So let's visualize the data so that we have a better sense of what are similar and what are not similar. Okay, if I plot the data points with the Z1 as the x-axis and Z2 as the y-axis, you'll see 4 points here. If you were to group the related point together, how would you group it? Okay. Well, how would you group it? Well, a sensible way is doing things like this. Why does it? Why should it look like this? Well, because if you look at the Euclidean distance as the difference between the 2 points, then it will look like 1 and 2 are similar because they are closer together. And 3 and 4 are also similar because they are closer together. Okay. So how does it apply to, practical problems? Okay. You might consider like the value of Z1 and Z2 are the pixel values in the picture. Then we will be grouping similar pixels together. Similar pixel values together. For example, pixels corresponding to the sky may all look blue. Okay, they may have similar pixel values. Well, actually, for simplicity, just think about a black and white picture. Okay, instead of having different color channels. Okay. So this is related to image segmentation problem. For example, if you want to separate the background and foreground, if you want to identify, let's say, tissues that are corresponding to a tumor, let's say you want to identify calcifications in a mammogram. Well, you will have to perform image segmentation first before you do the classification. And the image segmentation would be identifying the bright spot in the mammogram. Okay, how do you identify bright spot? Well, bright spots are those with pixel value that are high, and then you will group them together. But then it is not that all the pixel values that are high, you will all group them together. You also have to look at the location of the pixels. So image segmentation is more than just looking at the pixel value. You will also need to look at basically a planar graph where you consider neighboring pixels having an edge between them. Okay. Now, let's look at another example. Okay, suppose I have 4 features, set 1 up to set 4, and I have 2 instances, 1 and 2. Okay, how would you group them together? I mean, would you think of well, uh, well, actually, how would you group the features together, not the data, not the instances? Okay, how do you group the features? So I have 4 features. Can you say which 2 features are more similar? Does it make sense to do that? Well, let's plot the features, not the data points. Okay. Well, what I'm going to do is the feature set 1, I can plot it in a graph with x coordinate equal to 2 and y coordinate equal to 1. I can do the same for set 2, set 3, set 4. I get these 4 points. This graph looks pretty much the same as the previous one. It is because what I did is I just transpose the data matrix. So the rows become the columns and the columns become the rows. Okay, so when I plot it, it's actually the same plot. Now, if I look at this, then I should come up with the same conclusion. The 2 features, set 1 and set 2, are closer. Also, the 2 features, set 3 and set 4, are closer together. So I will group things this way. So does it make sense? Okay, so there's a comment about image compression. So probably that correspond to the previous slides. Yes, so an example of grouping similar pixels together would be also about compression. Now, but of course, image compression is quite a complicated technique. Indeed, it is not done in a way similar to data mining. Yeah, so for example, JPEG, it would use a technique, I mean, saliency map and all that to understand things that do not affect perception, can and to identify them, and also to put less importance in encoding them. Okay, so that is more complicated. Now, for grouping similar features together, now what is the application? Can there be something like image segmentation and those? Well, an application is actually clustering the genes. We can think of genes at each gene expression level. So normally people, well, how do they understand the genome? Well, how do they look at the genome of a person? Well, they would look at the gene expression level, and they would basically use some technique to analyze the gene expression levels. So every gene will have an expression level, and that could be a features of well, the person you're measuring the gene expression level. Okay, different people may have different expression of the gene, and they can be measured. And how do you identify related genes? You can look at the expression level and see whether they have similar fluctuations. Okay, an important application is to identify genes that have similar expression level. So maybe when in a patient, when the gene expression level for gene A is high, maybe gene B is also high. Okay, but if the gene expression level for A is low, then very likely gene expression level B is also low. So if you can identify this kind of pattern, then you would group the gene A and gene B together. Why does it make sense to group them together? Well, if you can identify related genes, then you can study them to understand whether they correspond to the same metabolic pathway. Okay. Yeah, I'm actually not an expert in the in genes, so I maybe some of you know what is well, know it better than I do. In well, what I know is there are many genes, and it is very hard to just study them without identifying the co-expressed genes. So it is important to break down the system into a smaller scale by identifying related genes, and then you can try to study what is their effect. Okay, so in that sense, clustering can be more viewed as a preliminary step in data mining. Co-express means the expression level are either are related, are co-expressed, just like correlated. So it can be that gene A has high expression level, then gene B has very low expression level. Maybe it is because they work together hand in hand for the same metabolic pathway. For example, if your glucose level in the blood is very high, then you will secrete more insulin, and then insulin will then convert the will trigger the conversion of your glucose to glycerin or something. I don't quite remember now. So if they work for the same metabolic pathway, they may have similar expression level. Okay, not similar but correlated expression level. It could be that one is very high, the other must be low, or something like that. The correlation can be negative, for example. Okay, so in that sense, Euclidean distance might not be the right way to measure relationship between features. Better way would be, for example, mutual information. Okay, if you look at the mutual information between Z1 and Z2, is the mutual information high? If so, that means the two features are highly related. They change, their change actually follow each other. Okay. Yeah. Okay. You probably can view feature selection as well, a specific form of clustering, but then you always try to identify related features to a particular target. So in that sense, it's not exactly clustering. Clustering don't have this particular, well, target value you want to cluster with. Okay, so I'm going to talk about a more particular algorithm now. We call partitioning method to clustering. Actually, it is not a particular algorithm. It's a category of algorithms that follow the same principle. Okay, so what is this? Well, the input would be a set of data points, okay, PIs. Then the output would be a set of clusters. We will denote the clusters as subsets of the data set. Now, this subset, we might enforce it to be disjoint, and most likely we are going to enforce this requirement. Of course, there are many extensions, variations. For example, the clusters, people may define it may allow it to overlap, but then for the purpose right now, for our course, we are only going to look at the disjoint clusters. Okay, now the challenge here, how do you perform this kind of I mean, how do you deal with this algorithm? I mean, how do you implement such an algorithm? Okay, there could be many data points, too many, so that you can't easily visualize them in a plot. Sometimes it may also be impossible to visualize the data points. Why could it be impossible to visualize the data points? Well, if you actually try to construct an example, you will know, because you will hit the constraint that if the dimension is beyond 2, you can't plot it in the 2D plane. If the dimension is beyond 3, then you would have to imagine it rather than plot it. So when the dimension is too high, okay, you can't just eyeball the data point and say what are clusters. Okay, so what is needed is a way to automate the clustering so that we can perform it on a data set that has many data points and also have a very high dimension. But what is the mathematical criteria we can use to automate clustering? Okay, so we now need to, again, similar to the information gain in decision tree induction, similar to the fold gain in the rule-based classification, that is a Reaper. We are going to find the formula needed to perform clustering. Okay, of course we are going to put similar things together, but how do we define similar and how do we put them together? Okay, so the idea is to have something called the typical point. Well, this is what we call the cluster center as well. They are the center of each cluster. For example, if we look at data point 1 and 2, they should be grouped together as a cluster intuitively. Then the cluster center would be the middle, like C1. Okay, and similarly for data point 3 and 4, the cluster center would be C2. Now, how do we think of, the other points in the same cluster? How are they related to the cluster? Okay, we will model it as kind of some noisy realization of the cluster center. What I mean is they are perturbations of the cluster center due to noise. Okay, so this animation shows that all the data points, point 1 and point 2, we assume them to come from the same cluster center, C1, but because of noise, they have different perturbations and they are located at different locations. Okay, so this is the underlying assumption. With this assumption, we can then think of an appropriate mathematical criteria to identify clusters. Okay, the question is, how do we recover the cluster center? Well, if we are given the set of clusters. So of course, we want to identify the clusters rather than cluster centers. But if we know the cluster center, then it seems we can also identify the clusters. So the question is, can I recover the cluster center if I have the clusters? Well, yes, we can think of the middle, the typical point, right? So how do you compute the typical point? Well, that would be a point that has smallest total distance, square distance to all the other points. So in particular, this C1 here would be minimizing the sum of square distance of the two red edges I show here. Okay, it's kind of in the middle. Now, the solution, what is the solution to this minimization? Okay, it is called the centroid. Okay, and you can actually write it out. The optimal CJ is equal to the sum of all the data point P. So here, each data point is a vector. So this summation is the component-wise summation. Okay, so let me give an example. Suppose data point number 1, well, is equal to the vector 2 and 1. Okay, then data point number 2 is equal to the point 1 and 2. 1 and 2. Then I will sum them up together component-wise. That will give me 3 and 3. But then after I do the summation, I divide it by the total number of points in the cluster, so that is equal to 2. So I would divide it by 2 and divide this by 2. And what it gives me is the point 1.5, 1.5. And this corresponds exactly to the coordinate of C1 here. This is how we can minimize the total distance to the other points. And this is how we calculate the cluster center. Okay, the method of clustering that try to identify cluster center like this is called the centroid-based method. But of course, the question is, how do we find the cluster CJ? This is really what we want to find. Okay, but once we identify the cluster center, wouldn't it be easy for us to find the cluster C1? Well, because points in the same cluster should be just some slight variations of the cluster center. Okay, so you can then try to group 1 and 2 to the same cluster by looking at their distance to the cluster center. Okay, so this is the idea. Well, we want one way is to try to minimize this summation. Okay, we choose the clusters so that the total distance is smallest. Okay, so let's look at an example. Which one would be a better solution? If I look at the, well, so first of all, let's try to identify the cluster center. Again, I would invite you guys to help. Let me see, let me check on time first. So for the interest of time, I think I will do it instead of letting you do it. Sorry guys, for the lack of interaction today. So I would, well, on the left-hand side, I already identified the cluster center C1 and C2. What about the middle one? Well, if the cluster look like this, then the cluster center would be at the center. And indeed, both C1 and C2 would be located at the same location by symmetry. Okay. And finally, if I look at the cluster on the right, then I would put the cluster center here, C1, C2. Now, which one minimizes the total distances? Well, on the left-hand side, total distance square. Well, remember the square there. Okay, we have this. So I sum up. So let me just use a variable a to denote the distance here. Then I would have 4 times a squared as the total sum of distance. Okay. What about the middle one? The middle one, I would have the distance here. Okay, the distance b, and then I will 4 times b squared. Okay. And now finally, this one. Okay, so I would get something like if I write it as c, I will 4 times c squared. Which one is giving us the smallest total distance? Okay, so you can tell me in a chat which one is smallest. Of course, I haven't computed the distance a, b, and c, but I can already tell what the answer is without computing a, b, and c. Well, by eyeballing it, I already know the order. A is smaller than B. B is B is bigger than C, so I just put it like this. Okay, sorry, B here. Okay. Then of course, because of that relationship, if I square them, the order still maintain. I can do it this way and the order still maintain. And then I can basically tell the leftmost graph is the optimal clustering solution. And it makes sense. We can eyeball it and and find the result. But of course, you would ask, okay, if I can identify it by eyeballing it, then what is the point of having this mathematical formula? Well, of course, when the dimension goes very high and the total number of data points also increases, it is impossible for you to just eyeball it and find the clusters. Okay, but this mathematical formula will still apply. And how do we get this mathematical formula? It is based on an assumption that all the points are variations of the cluster centers. Okay, so it seems to be a good solution. Of course, the question is, how do we know K? That is, how do we know the number of clusters? Okay, can I further minimize it over the choices of the number of clusters? Can I do that? Okay, let's try it out. Okay, suppose I further minimize over K. Okay, what would be the optimal solution now? If K equal to 2, then we have just calculated the optimal solution should be like this. Okay, and the total distance will be here. I look at 2 cluster center, and if the distance is A, then I will have 4 times A squared. Now, what about when the distance is, well, when the number of cluster, so this is for K equal to 2. For K equal to, very good, for K equal to 4, what will happen? When K is equal to 4, I will identify 4 clusters. And what is the minimum possible total distance? But distance is always non-negative. The minimum possible distance is 0. Can I achieve this with 4 clusters? Yes. If I put the individual data point as 1 cluster, then what's the cluster center? Well, cluster center is the point itself, and the distance to the cluster center, of course, is equal to 0. So if you choose K equal to, well, the number of data points, well, K equal to 4 here, then you will, in this case, it is going to give you the smallest total distance. In general, can you, well, of course, when you look at this, it doesn't look like it is identifying the correct cluster solution. In general, can you identify the clusters? Maybe I'm a bit unlucky. For this example, it doesn't work. In general, you can also come up with this issue. If you choose the number of clusters exactly equal to the number of data points in the data set, then you can choose the cluster center to be the point, each point in the data set. Okay, then the cluster just contains that particular point. And if you do this, then the total distance would be 0, right? And you will fail to indeed find the desired cluster. So it is not the right objective to minimize when you try to find the optimal number of cluster K. Indeed, this is known to be a very difficult problem to find the number of clusters, and we will not do it in this lecture. We are going to talk about it later. Okay. So another issues of this minimization is, suppose K is given, but can you solve this minimization problem? Well, it looks like it is solvable, but if you actually try to implement it and look at its order of growth, then it is NP hard. Well, actually, it can be proved to be NP hard, and the best algorithm is exponential time. Exponential in the number of clusters and also the dimension D. Okay, exponential. and of the exponent is with respect to n. Okay, so this is not good. Okay. Okay. So so what does it mean? We have a mathematical objective that sounds right, at least when the number of clusters is given, but it cannot be implemented. So then the obvious thing to do is, what about finding an approximate solution? And many data mining algorithms actually try to find an approximate solution. For example, the decision tree induction, it is not necessarily globally optimal because it is greedily choosing the best attribute to split. And similarly, for rule-based classifier, it is doing something like a separate and conquer. It is also at each step trying to find a feature that maximizes the thorough gain greedily. Okay. What about for clustering? We can also do things greedily, but how? How do we do things greedily? Okay. Do you choose the cluster center greedily? I mean, greedily according to what? Well, it turns out the first step, it doesn't make sense to have a greedy approach of choosing the cluster center. But what we can do is to select the clusters randomly, the cluster center randomly. So, you already have a set of points. Suppose you know k, let's say equal to 2. Then you can randomly choose 2 points. For example, point number 1 and point number 3 as the cluster center. Okay, of course you can't choose a non-existing point, not in the data set, because there are just infinitely many choices. You would randomly choose an existing point. Now, the next step is, well, you can, based on the cluster center, you can optimize the choice of the clusters. Okay, you can choose the cluster so that the the total distance between the cluster center and the data points are minimized. How do you do that? Well, you can do a nearest neighbor search. Just like nearest neighbor classification, you can build a KD tree or something like that to basically find the nearest neighbor. Okay, so well, actually, you don't need such a sophisticated technique. The easiest thing to do would be to go through every data point and compute its distance to the set of clusters. And once you do that, you can identify which cluster center is closest to that particular point, and group associate that point to the cluster of the cluster center. Okay. Now, the next thing is, once you have identified the clusters according to step 2, then you can compute the cluster center. But then you will ask, okay, why do you need to compute the cluster center? Don't you already choose? Haven't you already choose the cluster center? Like I have already chosen point number 1 and point number 3. But then if you look at this picture, they aren't really the center of the clusters. Okay, the reason is because when you randomly choose the point, you didn't care about what the clusters look like. Once you have identified the cluster, then you would need to recompute the cluster center to make it really the center, right? So you would then calculate the centroid of the set of points, and that correspond to these 2 points. Okay. Now, what happened next is when you recompute the cluster center, maybe the optimal choice of cluster has changed. Okay. And then you would have to recompute the clusters. And once you have recomputed the clusters, then you will also need to recompute the cluster center to make it consistent and so forth. If you do it repeatedly, you might get to a local optimal solution that minimizes locally, at least minimizes the total distance between the data point and the cluster center. So this is indeed what is called a k-means clustering solution. Okay, so basically just repeat until nothing changed. That is, the cluster center and the cluster stay unchanged. That is, you reached a settle point. Okay, it is you can really bring analogy to a gradient descent algorithm where you keep changing the solution until changing it result in zero gradient. Okay, now what is the complexity of this method? Okay, is it fast? Well, we mentioned that the solution to the centroid-based method, the exact solution is NP hard, and it's the best algorithm is exponential time. Then what about this k-means clustering, where we do things greedily? Suppose we need to iterate it t steps. Okay, so that is we need to repeat the computations t times. Okay, then the order of growth would be t times something. Okay, but what is that something? Can anyone tell? Well, let's look at the algorithm again. Each iteration, how much computation do I need to do? For the first step, t and k, very good. For the first step, I need to choose k cluster center, so that would be a factor of k. For the second step, what do I need to do? For every data point, I need to compute its distance to each cluster. So that would be k n times k that many computation. Okay. For the final one, I need to compute the cluster centers. Okay. Well, how much time do I need to compute? Is it, well, I have to compute k centers, and I have, in the worst case, the cluster contain n points, so it's also n times k. But actually, you can do it better because the total number of points is always n. So if you amortize the cost, then you don't need k times n. Okay, indeed, you just need order n. But it doesn't really matter because the bottleneck is the second step. So every iteration you need n times k that much computations. So therefore you will have this. Very good. Now, is it efficient? Well, the point is, well, if t is small, then it looks like very good. I mean, it is almost linear time. Well, if both k and t are small, okay. So indeed, in practice, k-means clustering run pretty fast. But what about the number of iterations? We don't know. I mean, there's no clear bound on the number of iterations. Okay, maybe it doesn't converge even after a long time. You might run into such an example, but those examples are pretty rare. That's why k-means clustering is a really practical solutions that people used for big data set. Okay, but as we have mentioned, a global optimal solution need not be locally optimal. For decision tree, it need not be globally optimal, and similar for all the other algorithms. What about k-means clustering? Is it optimal? Probably not. Okay, but to understand the issue, let's look at the same example and run the clustering solution again. So what is T? T is the number of iterations, meaning how many times you need to repeat. So the k-means clustering algorithm need to repeat the computations of the cluster center and also the clusters. And how many times do I need to repeat it? That is T. But we don't know, in practice, we cannot put a bound on the number of iterations because it's heuristic. I mean, it's a greedy algorithm, and how many times does it need to converge the optimal solution? I don't know. Okay, but does it even converge to the right solution? Let's check. Okay, just now it worked, but let's run the algorithm again. If I randomly choose the initial cluster centers, for example, I choose data point number 1 and number 2. Okay, I'm going to run the algorithm again. I would need to compute the clusters by minimizing the total distance. So how do I do that? Well, I will decide which clusters 3 should belong to. Well, should belong to cluster C1, right? 4 should belong to C2. That is, I mean, you can eyeball this and you can see this will be optimal. So something like this. Okay, good. Then you can see the cluster center are off center. So you recompute it. Okay, you put it back into the center. Now, then you try to repeat step 2 and step 3 and see whether you need to recompute the solution. Again, well, you will find that things are consistent. That is, you will still identify the same cluster C2 and C1, and you will still have the same cluster center. So now I have converged to another solution. Is it good? Not really, right? It is not the correct, I mean, the correct clusters that minimize the total distance. I mean, it's not the exact solutions. So the earlier one is a better solution. This earlier solution is better in terms of minimizing the distance. So the question is, what went wrong? I mean, I just carry out the algorithm twice. Sometimes I get it, sometimes I don't. What went wrong? So if you trace back the solution, the earlier solutions that is giving you the correct answer, then you can go all the way back and you find that the difference is exactly the location of the initial cluster centers. Very good. The initial cluster centers, the choice, it was random. And sometimes you are unlucky, you don't get the right initialization that will give you the optimal solution. Okay, so this is the problem. What went wrong is the random initialization. The initial choice is not good. Okay, but how do you know? And what is the chance of getting a poor initial choice? Suppose you are randomly choosing 2 points as the clusters, then how many choices are there? Well, you probably don't repeat the same point. Okay, so the 2 cluster centers probably should be located at different location. Okay, so in that case, you have how many choices? You have 4 choose 2 combinations. That is 6. So you have 6 pairs of point. Now, which pairs give you incorrect solution? If you do it this way, you end up with a wrong cluster solution. Well, what about the other way? What you can also choose this 2 and it will give you the wrong solution as well, right? If you choose this 2, no, it will give you correct solution, just like the second one. Okay, so you can enumerate it and you will find that, okay, this one and the other one are the 2 possibility where you end up in the wrong clusters. So that would be 2 out of 6, and that gives you 1/3 of the time you will fail. Okay, so is it good or not? 33% of failure. That is kind of unacceptable. Okay, so what is the fix? Anyone have an idea how to fix this? Yes. So if you are allowed to choose the midpoint, well, the chance may be lower. I don't know. If you choose this two as the cluster center, would it work? I don't know. You have to run the algorithm. Yeah, but still the chance probably may not be good enough. Can we get really small chance of failure? Very good. There's a private message sent to me. Yes, we can run the algorithm many times, right? And then we can choose the one that minimizes the total distance. We can calculate the total distance pretty fast in linear time. Okay, and once we of course once we have the solutions. Okay, but but sometimes we don't get the global optimal solution. So we run it a couple of times. And what is the chance that I fail after n times? That would be one. Sorry, not use n again. Let's say I run it m times. Then the chance of failure would be 1/3 to the power of m. And this number goes to 0 very quickly as m increases. So this is exponential decay. Okay, so this is actually what people do. You you do it a couple of times, and then you check which is the best solution. Okay. Good. Okay. So this is close to the final slides, I think. Let me check. Yes. So this is the final slide. Okay, and this is a challenge to the central base method. Okay, suppose I have the clusters. Well, I have the data point like this. What would be the desired clustering solutions, and what would central base solution give us? If you look at the set of point like this, the desired solution, what should it look like? Well, it looks like the middle 2 points, they are close to each other. So you group them together. And the outer ring are also a set of points that are close to together, and you will group it like this. So the desired solution should probably be like this. You have two clusters. One is the outer ring, the other is the inner two dots. What about central base method? What would it give you? Does it give you the desired clustering solution, or does it give you something else? Anyone? Yes or no? Anyone would like to attempt to think about this? So let's try to calculate the distance of if the two clusters are really the outer ring and the inner dot. So the cluster center for the inner one will be this. The cluster center for the outer ring, what would it be? It is also the center here. So the two cluster center overlap. And what about the distance? Well, let's say this distance is, well, you a, then you have 2a squared plus, well, then you have quite a bit of well, distance. Okay, so you will have you have all these distances here. Okay, so that doesn't look good. Why? Well, if you eyeball this and if you stare at it long enough, then you can probably see this solution, where the cluster center would be somewhere here, and the distance will be like this. Okay, so this is better than putting the center here and have the distance to all the points like this, right? So it should be obvious to you. Just looking at comparing the edges, edge length. Okay, so cluster central base method don't give you the correct solution, but the question is why? It failed because the two clusters have the same center, right? If they have the same center, how can you think of those two clusters as different clusters? It would be the same cluster, right? It should be the same cluster, but that is just not minimizing the distance. You would be better off by choosing k larger, right? K equal to 2 would be larger, and you can get a smaller total distance. Okay, so now what about if I modify the data a little bit like this? Then the inner two dot has a cluster center that is not exactly the same as the cluster center of the outer ring. Now, if I ask you in the exam, well, why central base method failed to find the desired cluster? For this example, you cannot tell me this. I mean, because they don't have the same center. Okay, but what can you tell me? Still, cluster central base method will give you something like this. But why does it fail? It failed because the cluster shape is non-convex or non-spherical. Okay. In the central base method, will identify convex or more spherical clusters. That is because sphere actually minimizes the total distance to the center. Okay, so that's why the cluster center should be more spherical. And if you look at the desired clustering solution there, the outer ring is not spherical, right? It is a ring, not a sphere. Okay, so therefore it is not, it cannot be found by the central base method. The question is, how do we resolve this issue? And that would be the topic of next lecture. Okay, so that is the end of the lecture. Then for the tutorial notebook, there's only one, and will also not be too much work as compared to the previous two tutorial. Yeah, so I will let you do it yourself. And if you have any questions, feel free to email me. Okay, so yeah, so that is the end. So you are, I'll stay behind for questions. Let me know if you have. And maybe I can, since there's no questions, I will take the time here to see if I can run the demo website locally on the computer. So this is, I think, the tricky part to see how it works. So let me try to do that. So again, I will go to the book here, and I will try to follow the step under the preliminary section. So I need to install Docker, which I already have installed it. So let me try to run it now. The reason why my computer isn't working very well is because I have the Docker app running. So it takes most of the memory of this computer. Yeah. So I have just started running Docker. It doesn't show up yet, which shows how slow my computer is now. Okay, so I have a running Docker now. If after you have run the Docker, you should look something like this. Okay, and then the next thing is to start the VS Code. VS Code is also open source. You can download it and install it. VS Code. Let me run it now. Okay, so I have now I have run the Docker the VS Code. So next step, the next step is I need to go to the view and then command palette and then enter remote container clone repository. Okay. Then after that, I need to enter this repository. So I will copy this repository first. Okay. Then this one first, and then open the view and then command palette, remove container clone repository in a container. So this is the one I used before. And I paste in this URL. So once I do this, then I have yeah, then I'm running the Jupyter environment, but I'm actually pulling the repository in a Docker image. Taking a while. Let's see. I'm starting it now. The first time you run, it will take a while because the image size of the CS5483 Jupyter is very big. It's more than 10 GB. But after you have downloaded it once, then the next time you don't have to re-download it again, so it would run faster. You can see after it has run the Docker, it will fire up the browser and go into the localhost lab interface. Now it will open the Jupyter Hub environment, sorry, the Jupyter server. And take a look at this server. It is the same as our server CS5483. If you look at the launcher patch, launcher, you can see the same kind of a set of apps. Okay, it is exactly the same environment. I'm using the same image to run the Jupyter server for CS5483. Now, you are actually running it locally on your computer now. That means you can allocate more memory to it if you want. You can also do more things. By default, I'm allocating only 4 GB of memory. All this can be tuned, can be changed. So for now, here you can also open the notebook there. For example, I can open the contents notebook. Okay. Then I can run this to import the IPython display code, and then I can use it to, let's say, display a big file. So this is storing the references of the report. Notice that you can typeset equations using LaTeX and also reference them. So you can, there are specific way to label the equation so you can refer it later. In the notebook interface, you don't see those equations, but after you compile it with JupyterBook, then you can get it working. So let me also show you how to compile the book. So in order to compile the book, you can open a terminal. So again, those instructions are inside the book itself. So if you go to the building the book page, then it will show you how to build the book. So I need to run the build.sh command in a terminal. So if I do this, so oh, sorry. So this is the binder. Just now is successfully launched, but I didn't have time to wait for it. So if I look at this directory, there is a file called build build.sh. I can run it, and it will ask me whether to clean the previous build. I say yes. Okay. Whether to build it, then I can click yes. So it will now start to build the book. And also, it will basically fill in all the equation number and get the references right. Okay. Then what about the next step? Once it has, well, actually, while it is building it, it actually re-execute the Jupyter notebook so that you will get all the output done properly. Okay. And there's one more command here. What I'm doing is I remove the previously built notebook, built book, and then I move the newly built book to a directory that is under the Jupyter server root. So what I would like you to observe is at the beginning, there's no www folder. And afterwards, when I run this command, okay, and when I refresh the view, sorry, yeah, actually it's under the server root. So this is the www folder. Now this contains the Jupyter book. In order to preview it, I can click on, I go back to the launcher window. There's a www icon there. Okay, when you click on it, it will open the server root with the www folder served as a web page. Under this, you have a directory called CS5483 Jupyter, and it will the book will be shown here. So this is how you actually compile the Jupyter notebook into a book, and you can see that the equation numbers, there's some issue with waiting for loading. Okay, so once it's loaded, the equation number are filled in, and this is hyperlinked, so you can link to here. And similarly, you can do this for figures. Okay, so this is the quality is pretty high, and you can see, and you also have the references done correctly. So these two references, when you click on it, it will link to the reference page. It is a separate Jupyter notebook that contains the references. Okay, and now if you want to, let's say, modify the number of memory to allocate, you can go back to the VS Code. This VS Code again open in the same Docker environment, but it doesn't have the Jupyter Lab server. Interface. Jupyter Lab server is actually run inside this terminal here, and is serving through your local host. So if you go to this div container, then you can you can check the memory allocation. It's equal to 4 GB, and you can change this and rebuild your server. So if I change it to, let's say I want to give it a smaller memory, okay, 2 GB, I change it to 2, okay, and then I save the change, okay, so save is Control S, and then I can run the command palette again. Let's go to View, Command Palette, okay, and use, okay, also remote container. So this is the command remote container, and one of that is called rebuild. Okay, so I can rebuild container. When I click on this, then it will restart everything, rebuild and everything, and with the configuration you have just changed. What you cannot do is you cannot push your change back to the repository, because you don't have the right access to the repository. What you can do though is to copy it to a new repository of your own, and then you can modify anything you want. Okay, so the connection is refused because I'm rebuilding the Docker. I'm rebuilding the container again, and it hasn't finished rebuilding yet. Once it has finished, then it will run the Jupyter Lab service again. Okay, so that is indeed the way I would think ideal for project 2, because you have the Git version control. At the same time, you are allowing other people to reproduce your results, and at the same time, you can launch the notebook directly to our server to utilize the GPU resources there if you want. Okay, so things has rebuilt, and then it is going to launch the notebook again to the server. Okay, and this is like so now it is starting the Jupyter Lab. My computer is pretty slow, but if you have a faster computer, yeah, I'm actually also using Mac, but for lectures, because I use a pen, I use the laptop, which has a pen in it. So, but this is pretty slow, I would say. Anyway, it has probably rebuilt, but then it is slow to start the Jupyter Lab server. Probably I should look at this page. Yeah. Yeah, it has rebuilt. So it's just take a while to launch to the web browser automatically. So if you don't want to wait for it, then you can just directly, so now it has auto launch to the browser. Okay, so I don't know why it can be slow to automatically launch. Okay, so that is how you can build this book. So yeah, indeed, this is the way I built all the all the Jupyter notebook for this tutorial assignments. Okay, that's all. I think. Any questions? If no, then I am going to start now. Okay. Have a good evening.